Um, Welcome again to everyone. I welcome you to the joint DST webinar between PrAEctiCe, CIRAWA, CANALLS, and NATAE. My name is Blessing Shoriola. I know we are all already familiar with me, and I'm the communication specialist for the PrAEctiCe project. The PrAEctiCe project is an Horizon Europe project that is funded by the European Commission. And I welcome you again to the DST webinar titled Digital Innovation in Africa in context of the decision support for agroecology. And the main objective of today's webinar is to disseminate and to showcase the decision support tool that has been developed by each of the projects, and to also showcase the functionality and the usefulness of these tools to promote agroecology, and also for CIRAWA, who has also developed a platform that helps smallholder farmers and stakeholders collaborate to also promote agroecology. I'm super excited for this webinar, specifically for critical discussions about technology and innovation that is ongoing in the agroecology space, and also the knowledge exchange between the projects that are participating in this webinar, and the exchange of knowledge and expertise between these projects. Without further ado, I will just go ahead to welcome Nicholas Minari to go ahead with his presentation. And then after him, we'll have the PrAEctiCe DST presentation. And then we'll go ahead with the CANALLS presentation and NATAE's presentation. And then after that, we'll just open the floor for discussions and question and, exchange of knowledge. Just open the floor to, anybody that has questions from each of these presentations. Nicholas, you can take the floor. Thank you.
So, do you see my screen? Yeah?
Yes.
Yeah. So, thank you so much for joining us today to discover Landfiles, the collaborative platform that's helping technical groups making the agroecological transition. Landfiles was born in 2018 from a pretty straightforward idea. How can we help groups, whether they are small or large, share their agroecological innovation while keeping their data secure? Today, we are trusted by nearly 50 organizations, and more than 5,000 people use Landfiles every month across Europe and 6 African countries. So today, we are going to explore the Landfiles application through the CIRAWA project, but we'll also show you features that other projects use to give you the complete picture of what the platform can do. The CIRAWA project is deployed across 4 African countries, Senegal, Cape Verde, Ghana, and the Gambia. Each country is responsible for monitoring 25 plots using the Landfiles tool. There are 2 main objectives here. First one is to collect data through the application that secures storage and processing. And second, to share plot insight and updates with the entire consortium. In a few months, these plots information will be opened up to external partners through a public page. The project really shows the collaborative and international side of Landfiles perfectly. Just right now, I'm going to show you the application, the web application, and later on, I'll show you the mobile app that works even when the network is weak or unavailable. In CIRAWA, each country has its own dedicated space. Local technical teams are in charge of documenting their field observation and sharing them with the entire consortium. Let's look at a few concrete examples of plots that are being monitored in this project. First example is this plot number 1 of Senegal River Valley. I go here. This is a 2-hectare plot located in Sanente, Saint-Louis in Senegal. It's a diversified farm, practices market gardening and arboriculture with a sprinkler irrigation system. Main crop include cassava, 8 tons per hectare, peanuts, orange flesh sweet potato, and rice. The plot faces soil salinity challenges near the lake and applies agroecological practices like intercropping, crop rotation, and compost production. Mixed livestock farming, goat, sheep, cattle, chicken complement the agricultural system with manure valorization. You'll find a whole series of observations recorded over time. Recent monitoring show promising agriculture development. The introduction of orange flesh sweet potato in early 2025 has proven successfully with good yields after 3 months, gaining popularity among neighboring farmers. Rice cultivation demonstrates excellent germination rates with minimal weed and disease pressure. The plot is actively testing agroecological practices for improved productivity and water management in challenging sandy, saline soil conditions, while monitoring showing healthy plant establishment and good water infiltration despite variable climate conditions. Here we have also detailed data that have been saved by the technical guys on the field. Now let's take an example from Cape Verde, the Campo Experimental Mourinho Caleta, located in Mayo Island. This experimental plot underwent progressive development between February 2024 and November 2025. In landfills, we can track initial clearing. So that's here at the end. Initial clearing, establishment of a nursery, producing species adapted to semi-arid climates, moringa, tamarind, hibiscus, aloe vera, palma for Agera. Then implementing agroforestry system and application of agroecological techniques like assisted natural regeneration of acacia and mulching. The plants produced were distributed to farmers in the CIRAWA project, and rain crops, corn, beans, melon, watermelon, were successfully cultivated in the interrows despite low rainfalls, as you can see here in the picture. So, yeah. So we have on this plot 8 observations that can document the progression with a lot of pictures that are very interesting to look. Let's go now to the, sorry, no, not that one. To the example from Gambia. So this plot number 11 in Lower Badibu Tobora. That's the characteristic of the plot, so located here in Gambia. With so details here. This half-hectare demonstration plant is managed by Mamadou Loum, who is 44 years old. It showcases an integrated farming system that combines vegetable production, tomato, cucumber, eggplant, sweet potato, chili pepper, also fruit trees, banana, cashew, mango, orange, and lime, agroforestry species, Gliricidia, Luciana, and poultry production. So here you can see also the observation. This plot is manually irrigated from a 2,000-liter water tank supplied by
at forecast 180.
With extensive use of organic fertilizer from animal manure and compost. So this farm demonstrates sustainable practices, including crop rotation, intercropping, biological pest control, and successful rainy season vegetable production with improved varieties. So we have 7 observations recorded between August 2024 and October 2025. I go again to the CIRAWA group. So what this means for the team? Picture this. You're a technician in a country, for example, in Senegal, testing out a new intercropping practice. In just a few clicks, you publish your result, and your partner in Gambia, Ghana, and Cape Verde can immediately see what you're doing and ask questions. That's the power of landfills, getting innovation to circulate quickly without barriers. And all of this happens securely with precise access right and a plot history that preserved over time. Each organization keeps the control of its data. Now I'd like to show you the mobile app. So I'm gonna share the screen from the mobile app to show you the application. Oh, okay, I have to stop the sharing here. I'm not sure I can. Okay. It's not working, sorry. So what I can do is just to explain to you the mobile app. That will be enough, I think. The real strength of Landfile is its mobile application. During the speak, I will show you just other pictures so you can have nice pictures to see. So the mobile app is available on Android and iPhone and designed for field conditions. So you can enter observation directly from the field. The app work offline also. If you have no network, then no problem. Your data are synced automatically when the connection is back. And also you can easily fill the different forms and add picture, of course. You can use the application, the web application or the mobile app to fill the different forms that are available on the app. So let's take the example here. We've got different forms that have been designed for CIRAWA project. So as you can see, there are different thematics here. I can select all of them and show you. So for example, we've got here, we've got different sections of data that has to be entered. Here you can see different sections. So crops cultivated in last year. We've got different fields for different varieties. If you apply fertilizer, Then you have the type of fertilizer, organic, inorganic, etc. So all the details have been decided by the consortium and then implemented into land files, and everyone has had to or has to save the data on his plot. So if I go back to the plot I showed you before, so for example that one, the users had to enter all the information here. So the data are secured and private, and they can be downloaded by the manager of the project. Then you can build automatic summaries in the app. So that's an example of maps that you can build in the apps. Or yeah, let's take for example that series histogram and trend curves. Or we can have also comparison table like this one. This tool was built with University of Wageningen in Netherlands in order to show the different tree species. So the users are able to filter the tree species here corresponding to their field conditions. And the tool is able to select into the database the tree species that are according to the characteristics. And we can select one and have a look of the different observation answering of these tree species. So this is fully configurable and can be applied to other species like crops, intercropping, or what you want. Landfiles is not just a data collection tool, it's also a community engagement platform. So you have the capacity, you have, sorry, a document library available to share PDF, Excel file, picture of the whole group, as you can see here. So you can really share a whole set of documents with your group. You can have events calendar with registration management. So here you can see the different events available, and you can indicate if you participate or not. You can also build in few minutes newsletter to share observation with your group. So let's have a look here on the newsletter we sent a few weeks ago. So it really takes maybe 5 minutes to build such a newsletter. So it's really easy to build and program with land files. And you can have also public pages like this one here, able to show what you have done. So this is, you can see these public pages without registration in Landsat. You can have a look on the details here and then register if you want. So it's able to give an access to your observation to a wider audience. Everything is centralized in one place. No more, you don't need multiple tools to do all that jobs. What I can show you also is that land files is fully configurable. So you have here in the administration page the capacity to build your own forms by yourselves. So with that tools here, you can edit, you can add new data, new sections, etc. Everything is on your hand. You can also have multiple parameters to build public page, to build your dashboard and maps, and or your document organization. You can also build new questionnaires, etc. Yes, so I'm finished with the presentation, and I wanted to discuss with you. So just to sum up, Landfiles, it's a collaborative platform. It's a collaborative platform that combines data collection and processing, technical group engagement, knowledge capitalization, multilingualism also, because we have 10 languages available, and so we are ready for international projects, and fully configurable. So, maybe today, all right, we reached the end of our project presentation, and I propose now to discuss with you and to see what is your feeling about the app, and if it would be interesting for your project, and to share also what we have done in CIRAWA with you as your other external partners. Would you be interested in accessing the different observation the people made within CIRAWA with you?
Thank you very much, Nicholas. I think by the end of all the presentation, there's floor for conversations and maybe future collaborations as well. Thank you. That was a very interesting presentation. I was personally interested with the fact that there's an ability to use the platform even without internet usage, which is specifically in Africa, some of the worries that we have, in Africa, the network issues and all of that. So the ability for farmers to be able to disseminate and cross promote their farming activities. I think that's very, very interesting. Thank you very much again for your presentation. We'll move forward to the PrAEctiCe DST presentation. Mate Bruman from the University of Maribor, you can take the floor. Thank you.
Okay, so welcome to the PrAEctiCe DST presentation. I'm Mate Bruman from University of Maribor. I'll present the DST. So let's jump straight to the content that we'll discuss today. We'll go through a little bit of introduction, then methodology, why we are doing things that we are doing, and then I'll explain some components that we developed and conclude them in a summary. So what are the PrAEctiCe DST fundamentals? It's a GIS-based design, so it means it leverages the GIS technology to enable spatial data visualization and analysis for integrated aqua agriculture. For instance, it integrates the different data sources, so we can have like raster maps, satellite images, geometry maps, sensor measurements, and manual user inputs all present into the unified view. With this, we give support for farmers, extension agents, and data scientists to collaborate essentially on all of these data available and to provide tools. So what is the geospatial data? It's essentially any data with a known real-world location. Here are some examples. For instance, we have some geospatial geometric layer that maps the soil boundaries and soil classification in East Africa. Here is Uganda, Kenya, and Tanzania, for instance. And then we map some value to, or we attach some value to it, like amount of nitrogen reserves within these soil types, for instance, averages. On this image, we can see the satellite output in form of the normalized difference vegetation index and so on. So we get idea what is the geospatial data. Next, we have temporal data. This is any data with a known time of measurements, date and time, for instance. This could be temperature or any kind of IoT data that we can get that has a known time. If we combine it with location, it's even better than we have like spatial temporal data. So what's this important? Because it's important for the methodology that we are using, that we need to have consistent data. So methodology that we are using is JDL Data Fusion Information Group methodology, which describes data processing and assessment into the multiple different levels, going from really raw data towards really high-level data representations. So we start with level 0, which is generic data assessment. Here we essentially pre-process raw data from multiple sources like sensors, spatial databases, satellite imagery to ensure quality and consistency before we can go to any higher data fusion levels. These tasks include like filtering, calibration, data transformations, spatial temporal registration. So we align the time and space into the same unit, geometry reprojection, so we can fit everything on the same map, basic segmentation of feature extraction, for instance. Next level, level 1, which is about object assessment. Here we estimate the state of the individual entities or objects of interest. This could be, for our case, fields or ponds that are on the farm. And then we have different tasks that we can go through. For instance, first one is classification, where we can ask ourselves questions. Okay, which crops are we currently growing on the field and how to achieve this task? And then next example would be which fish are we raising in the pond, for instance. So we have object, which is field or pond, and what is on that object. We can also do detection. Are the current soil moisture levels okay on that field? Are there any crop growth inconsistencies, and so on? We can estimate things on the specific object, like how many fish do we have within the pond, what is the average crop height, and so on. Okay. Next level is about the situation assessment, where we try establish a relationship amongst multiple different objects. Can be same, can be different, to understand the overall context. Here we have tasks like contextual analysis, where we ask ourselves questions. For instance, should we reuse water from ponds to irrigate the fields, or we should continue using the different water source, for instance? Or are temperature and humidity from weather data, which is another object, posing any fungal disease risk on our field? And another question is solar panel power output sufficient for irrigation pump demand, and so on. And then we have like pattern recognition tasks, which is detecting disease spread trends across multiple fields or identifying irrigation stress patterns, and so on. And next level, which is last level about the data, is the impact assessment, where we try to predict the future states, knowing the past state of our situation and different objects. So we try to assess consequences or evaluate risk and opportunities. Here we have like simulations and predictions. With simulations, we can simulate irrigation schedules for different rainfall scenarios. For instance, with predictions, we can predict crop yield based on the current growth, weather trends, or soil conditions. So we basically do entire data fusion to get some information. I'll skip the process refinement. This is not important. The most important is the level 5, which is the user refinement that enables users to interact with the data fusion process, view insights, and make informed decisions. So this is essentially the DST part of this entire methodology. So we do this through visualization. We let users see the results and perform analysis to make these decisions. We provide tools like editors, where we let users edit the data, correct the results, or provide inputs to establish a feedback loop to the system, and personalization, where we try to build different applications tailored to the different end users, such as the data scientists with more control, extension agents with more insights, and farmers with easier to use applications. So what are the components that we implemented? Essentially, we have like 4 different components. The first component is the central platform that stores all necessary information in files and databases and exposes services to the client applications. Then we have client applications. This is the indicator monitoring center, which enables data access, data edit, data processing, data visualization on a really generic GIS level. Then we have tailored applications for the extension agents. We call it PrAEctiCe Advisor. It includes a limited subset of indicator monitoring center features and adapts its user interface to be suitable for extension agents without all the complex tools. And on the end, we have a PrAEctiCe Farmer, which is tailored towards the farmers, where they can check latest state on the farm, see the alerts, potential solution towards to remedy those alerts on their farm, and also provide additional inputs to the entire system. So we will talk about central server platform. It's targeted towards the extension agents and data scientists. The capabilities of the platform are to manage primary and secondary workspaces. Then on the per workspace level, they can manage central storage and databases. needed for all kinds of data analysis purposes. They can configure services on the workspaces and assign API keys for the data access to provide the access to the client tools and limit the access what anyone can access, so there is a secure transmission in between. And they can also configure tasks for automated data harvesting and processing to periodically harvest data from various data sources. How it's used? Well, primary workspace contains spatial databases about farmers, farms, fields, ponds, infrastructure objects, IoT data, and questionnaires. And it essentially provides the services to advisors or extension agents and farmer applications. Secondary workspaces are essentially used for data analytics scenarios to model cases that are not possible through the dedicated application directly. So we basically gather all the data there, perform some analysis, get some insights out, and publish the results to the main workspace, for instance. With the indicator monitoring center application, which is targeted towards data scientists primarily, but also used by the extension agents, we enable them, for instance, to edit the geospatial layers, like which farms are we having, which fields are we having, which ponds. So basically any GIS operations that are needed to establish the correct data fusion process. This application provides access to geospatial data through various standardized sources like OGC services, ArcGIS, online, custom databases. You can even put in the local datasets. Its local application runs offline. If you have local data, you can only operate on the local data without any issues. It also supports the platform integration where you can access the workspace storage from the platform and databases directly and view the data directly within this application. And what's the most important is it supports custom data processing and AI workflows. So for instance, we can design our own custom pipeline to do some analytics. For instance, here's the example where we get weather data, where we get satellite images, we retransform the weather data so the AI model can understand it, and this AI model tries to estimate how much of the fertilization amount you should apply to any section, any part of the field. And it generates this kind of map. It clips to the geometry of the fields, and we can see the results, for instance. So this allows us to do really detailed analysis about situations going on in the real world. Then we have Practice Advisor, which is targeted towards extension agents. This application it's basically a dedicated tool for extension agents. It displays all the sensor data from managed farms, questionnaires inputs, focuses more on data insights rather than data management. So there is not much of the editing tools revolved within this, implemented within this tool. And essentially key benefits are simplifies decision making for the extension agents. They just focus on what they need. They can define custom indicators for the different properties and soil, crop types, and so on. And they can essentially offer assistance to the farmers through this application because they can see everything that's going on the farm. So we'll go a little bit through the features. So first, their tool is composed from different components. The first one is for the indicator monitoring. So what this allows? This allows advisor or extension agent to quickly jump between different farms. When they jump between different farms, they can see what infrastructure is on that farm. For instance, okay, we have some fields here. We can select the field, and then we will see all the different measurements that are on this farm. This can be from automated sensors or questionnaires or or automated processing tools, for instance. We call all of these observations. And for each observation, we can link it to the specific indicator that we defined to monitor its progress. So with monitoring progress, what we mean we can track through the time what was going on with a specific measurement or combined measurements. It doesn't really matter. If it has the time and some value that can be represented, we can put it on the plot. And here we also show on the bottom, we show which indicator is currently mapped to the observed variable and what is the status and potential solution. For example, here we see that currently it's in the green area, so soil moisture levels are fine for this field here, and we show some info of how it's composed together at the different soil depth levels. And we can also see that it was not always in the green zone, so it was a little bit below the optimal moisture levels. And here in the past, we can see probably due huge rainfall that it was also above the recommended levels. Okay. So to define those indicators, we provide tools to the extension agents so they can create new indicators. They can fill in the tags, type of the indicator, name, some description, and some content revolving it. They can add new categories for different crops, different plants, fish, soils, for instance. They can define different properties for the different observables, like name of the property and unit in which is measured, because this is really important if we want to automatically convert between different property values, property units, for instance. And they can also define the scopes, what would be the bad indicator, what would be a good indicator, for instance. Here they can also define, like, is this alert, is this alert, or is not alert. Like we have like normal scopes, like warning and critical. So we know how good is something behaving or not. Then, for instance, we select the indicator, we select the category, property, and we can define ranges, which is for the critical, which is for the warning area, and which is for the normal. And we can also provide the solution. Okay, if it's critical, you need to do this, and this to mitigate the issue. So all of this information is then presented to the farmer through the farmer application. They can see and they can react to it. So last component that I'll talk about is analytics capabilities within the PrAEctiCe Advisor, where extension agents can see really detailed insights into all the devices present in the farm. So here we have like device dashboard, where we can view device state for the past day. We can jump between different sensors. We can open it to see more details in form of the plot and the table view. Next, we would have the detailed chart views that support data aggregation and resampling through simple controls. Here we can select different sensors from one device or between multiple devices and compare those. We can also select different sensors with different properties and put it to the same plot and rescale the values. So then we can, for example, check for any correlations that we can see in the data. And in the end, we also have the data view where we can export all of the data either to CSV, to the Excel file, or to the clipboard and use it in the other applications like Indicator Monitoring Center or Excel and so on. Last application that I'll talk about is the PrAEctiCe Farmer. It's meant for the farmers where they can, it's a basically mobile application where it provides the latest farm state to the farmer. It shows the alerts for the critical conditions from the monitored data, and it recommends the solutions for those issues, like seen here. Application also provides farmers with questionnaires, which is useful for measurements that are not automatically sent to the platform. For example, we cannot measure automatically everything, like, I don't know, how high is the crop or what is the length of the fish. For example, we can enable these inputs through the questionnaires. So questionnaires include parameter selection for which crop, plant, or fish are present on the farm. And then we get different sub-questionnaires for different crop category, fish and soil and properties, and all the other infrastructure objects that we may have sensor, but it's not automatically integrated to the platform, so we can read the value and input it through the questionnaire, for instance. So what are the features of the mobile application? It offers the interactive map where we can see the farm state. We can select different objects, like click on the field and then show details to see detailed description of that field. We can also click on the sensor. We can see sensors locations and click on them to see the data and so on. It also offers to synchronize the proposed schedules to your calendar. For example, here we have schedules like how often should fish data be collected. We can add this to the calendar to be reminded daily, for instance. We can do tasks like fish growth analysis, which should be done once per week, or fish flash analysis, where we sample the fish and then provide those inputs manually once per month, for instance. And then we have latest farm status that we see like in one page, everything that's going on the farm, to see all the alerts, all the recommended solutions. Like here we have ammonia levels that are too high in one of the fish tanks, and then we propose solution like stop feeding, introduce fresh water, take out some of the existing water, or stop introducing the manure in case of the one of the linked labs, install air pump or oxygenator to introduce more air into the pond, for instance. And we can also see if all the data that was selected by the extension agent that the user will be able to see. Okay. Next, the questionnaires. This is the essential part of this application because it allows us to downscale the application to the general audience without advisor, so they can still try to benefit from the DST even if they don't have farms, fields mapped, ponds mapped, and everything so on, even if they don't have the sensor infrastructure and so on. So what they can do, they can essentially enroll through the once questionnaire, where they select which species they grow, like fish species they grow on the farm, what are the crops that are planted, and so on. So the system will then generate all the questionnaires for these crop types that could be collected from the user. So then users just use those questionnaires and input the parameters for the tilapia measurement data, for instance, how much do they weigh, what is the pH level of the water quality, and so on. They can name the ponds and farms, fields, what they measure, so they can get unified view in the latest farm state, because all the outputs are listed here, and if there's indicator mapped to it, it will also show the solution or alert that something is wrong. I mean, if it's good, it will show a green color, or will not show anything, and if it's red, it will show like you need to take some action to solve the issue. So in summary, end users' benefits are, for the extension agents, they get streamlined data insights, custom indicators and solutions they can create essentially on their own, and they get really detailed analytics into what's going on the different fields in the farm. Farmers get real-time farm status, alerts, solutions for those alerts, interactive maps, and of ability to provide additional input through the questionnaires. So key components that we presented today were central server platform to data storage, indicator monitoring center for really detailed data analytics to figure out what's going on with the different farms, why something happened, to answer those kind of questions, and then we have dedicated applications for the extension agents and farmers that provide the insights and alerts and recommendations, for example. And we offer data-driven tools and analytics. So the data scientist teams and extension agents, if they have an entire team working on this data, they can directly access to really reach multi-source data sets that consist of multiple sensors, spatial, temporal data, and manual user inputs from the questionnaires. tools for advanced data processes, AI workflows. They can, for example, data scientists can prepare one AI workflow, and then the extension agent can execute this AI workflow on his own data or her own data, for instance. We have ability to really develop and refine models, validate predictions, and really automate processes through these kind of tools. And DST also offers extensibility. Due to its modular design, it enables future DST enhancements, so we can use it in the future. It's not like it's really extensible, what I want to say. So we can add new decision logic to it, update existing logic, and we can integrate additional workflows for the different analysis. So the extension agents can benefit from this. So thank you all. That's it.
Thank you very much, Matej, for that extensive presentation. It was very detailed, and I think one thing I also got from it was the show of detailed data view for extension workers to make comparisons in their data, and for them to be able to make informed, farming decisions, and also for farmers. The display of the critical alerts that also proposes solutions for them. I think that's very, very useful for farmers. And of course, the questionnaires, the questionnaire function of the application that allows them input specific data and to be able to, offer, specific solution or specialized solution. So yeah, that's very, very useful solution. Thank you very much again. We'll move on to Beatrice Arena to give to present the CANALLS DST2. Thank you.
Yes, thank you. And good morning, everyone. My name is Beatriz Herrera. I work in the University of Hohenheim, and we are part of the project CANALLS. And I'm going to present a tool that we are developing for advisors in the support for agroecology transitions. This is a collaborative work from CANALLS. CANALLS has as an objective to promote agroecological transitions in humid tropics of Central and Eastern Africa via multi-actor transdisciplinary agroecology, living labs. So we are working in Rwanda, Burundi, Cameroon, and the Democratic Republic of Congo. We work with 8 living labs, mostly working with cocoa, coffee, and cassava and rice. So, sorry. My presentation is divided into 2 parts. The first part, I am going to talk about the development process, what is the problem behind, and why did we use a user design approach. And then the second part is about a tool, Agreco. I have to say this is only on the prototype level, so it has a technology readiness level of 5, so it's not ready to commercialize. And what are some implications and outlook for the future? So the first is a little bit the background. In CANALLS, we are concerned about in general, the agroecological innovation systems and what is the role of digitalization in agroecological transitions. So there is a promise that digitalization can accompany agroecological transition process, but this presents a double challenge for advisory work. First, what is agroecological transition, and then how digital transition supports and work with agroecological transition and not against it. And the other thing that we had observed is there are plenty of digital tools that are being developed, but the uptake of these digital tools is still very low. And one of the reasons why it's still very low is because either it's not adapted to the digital readiness of the user, or because it's not impact-oriented, or because it it doesn't have involved what you say the fair development of tools, which is including the user in the beginning, and also making a fair governance of knowledge. So it's expected that the co-design or involvement the user in the design of such tools can increase the uptake of those tools and the adaptation to the user's needs. And that's what we thought that this user-oriented design comes in. So what we use for the development process, we use the design thinking approach that has two phases: identifying the challenges, identifying the user's needs, the expectations and experiences, making a literature review or in general a review of the tools available, and then making what we call a requirements elicitation. And then we prepare the concept and the prototype, and we make the first testing. So the problem here is that in general, in those crops and then agroecology, there are fragmented advisory systems. We have advisory systems from companies, we have advisory systems from governments, we have advisory systems at the local level, from projects, from development projects, from research action projects, and there are all different workflows, different objectives, different resources, different digital readiness level, and also very important, there are different crops or farming systems in place. So our challenge was how to develop a tool that, given the different conditions of advisory work in this context or in the context where CANALLS work, can support agroecological transition. And we use these steps. First, we look at what were the agricultural systems that we were targeting, and then we try to identify the advisors' needs and the readiness level of the advisors. Then we try to understand what are their needs and try to empathize what are the main problems. And after that, we develop the modules, the indicators, and the interfaces that can support those needs. And then we create the concept and the pilot, and we are in the prototype level, making usability tests and making adjustments before pretesting and scaling the system. So this is what we did, the different phases: identify the needs, interviewed with researchers and advisors, analyze them, then we review what were available in the existing digital tools. Perhaps it was easier to adapt one already tool developed than create one. And then we assess the feasibility according to the objectives and time available. We created the first concept, and it was agreed with the project members, and we identify requirements. And a very important step, we prioritize the requirements, what was a must-have or a nice-to-have. And then we identify indicators and interfaces for the different agroecological frameworks available. We define indicator questions and potential reports. And then for the prototype, we test, and we are in the process of improvement. So what we conclude from the first phase of advisory needs and from the research that we do is that advisors need a tool to improve the way that they have a dialogue with farmers, and a tool that improves the activities or the impact of the activities that they have, and also that they increase the way that farmers' knowledge and advisors' knowledge can go together. That means how can they agree on what to do to make practices that are beneficial for the farmers, but also that allows the advisor to achieve their own goals. And other needs that they have is the need to show or to present what is the impact of the advisory activities. How can these advisory activities be easier done? Actually, being an advisor is a very hard and very bad paid task. So how this task could be improved in the field. And then other important aspect is, because there is no consensus what agroecology exactly is, to improve the skills and knowledge advisors and the capabilities of advisors to promote certain topics of agroecology. And then to improve the collaboration with other advisors and groups. And a secondary need is to improve let's say, how the data is analyzed for research processes or for development processes, and also to generate relevant reports for the people, for supervisors or for funding agencies. And from these needs, we identified what is required from the DST. And here, priority is what the DST should provide data-driven recommendations for farmers, number one. Then it should support the reporting and data transformation, that also very important. Then it could be a way to present training materials and resources to facilitate work, and then a networking and collaboration platform. Secondary things that we also identified is like a repository for success stories of advisors or management of appointments or optimization of routes and real-time data correction and management. So the concept that we have that somehow comply with these requirements is that it can work with different extension subsystems, support the workflows of extension agents, adapted to the digital readiness, is oriented towards farm systems, not only to cash crops, can work offline, and contribute to the development of skills, capacities, in other words, to the professionalization of the advisors in giving advice. And we call it Agroecology to the concept, and again, it's how the dialogue can be done between extension agents and farmers. And our main assumption here is the advisory works can support the principles of agroecology. Here are the 13 principles of agroecology. And the point with these principles is that as they are principles, they are not easy to operationalize. So what we use is we use the Vision Fact tool with says that okay, to operationalize these principles, we need to look concretely at what indicators at soil, water, crop, livestock, trees, pest and disease, energy, household workers, and community and value chain can be affected. And then we use this framework to develop the indicators in which the advisory work should have impact. And we develop for each of these dimensions indicators. And this is included in the final concept, which has 3 points or 3 elements. The mobile tool for documenting farmers' problems and practices that work offline. Then the web-based tool that is a tool for learning, planning, analysis, and reporting. And then a printed tool that is about a dialogue and making sense of the data and the reports generated by the mobile tool and the web-based tool. This is a little bit more how do we see it. We use ODK because it's quite extended, and we thought that it was very nice for the sustainability of the project because very extended in all these communities. And then we have the base tool that provides the analytics of it, and then we have the didactic material which provide recommendation between the extension agents and the farmers. As secondary actors here, we have the research that with information can make analysis of the changes in the agroecological situation and other societal actors, and also the supervisors or project managers. So here's the mobile tool. How does it look like? Basically, it's a questionnaire for data collection and works completely offline in several languages. And it works to tracking the advice activities, what concrete advice activities are taking place in the field, allows comparison of changes between time from farmers. So it's possible to register the same data in different points of time. It allows you to collect data about localization, georeferences, pictures, and allows small calculations that can be done in the field. Yes, and every component or every element of a component of the agroecological is included there. And it works only with Android phones. Now here's the web-based tool. The functions that it allows is the report of advisory activities. This is with the intention to facilitate the reporting and registering and tracking of activities of the advisors. Then it allows to track changes on indicators and agroecological indicators on time of farmers, so the agroecological diagnostic. Then it has a section of training resources and also a section for sharing with peers and collaboration. This is, for example, the report of advisory activities. It allows to see, let's say, the changes into activities, results, outputs, and also collect data in forms of pictures, even voices, and then track changes of agroecological indicators by farm. For example, here it's possible to see what are the indicator dimensions, what is the current situation and changes for a specific farm. And also the training resources, let's say what is public available of agroecology, and also sharing with peers. And then the printed tool. This is more a pedagogical visual tool. So the idea is to have it printed, and it's a tool that allows to train farmers on agroecological principles, on concrete practice activities, and very important to sense making of data and reports. So we tested the prototype, and in general, it's very easy to use. There are still semantic barriers and in the questions and in the answers. So this should be tested and retested again. Those who have collected data from the field knows that this communication is always a challenge, not because of the language, but because of how the question is asked and what is the answer to be responded by the farmers. And then, it works with different digital readiness level for advisors, but it's necessary for some type of advisors to train in the use. It works with different workflows, but it also collects data about factors affecting work, and also has a lot of opportunities in the use of data and in changing a little bit the role of advisors, not only as providing information, but also collecting information from the farmers. So what we have learned a little bit is we should consider the user when designing these tools. And one very important aspect that is usually not taken into account is what is the farm advisor career journey. The tool allows to operationalize complex conceptual frameworks. So in other words, it's a tool for capacity building of advisors. And because extension systems are very diverse and depend on a lot of geographical, cultural, and economic context, this tool should be have this flexibility on changing the concept so that indicators could be somehow weighted differently and allows for that. And that the co-design might be a way to dealing with uncertainties and to avoid potential risks of digitalization and aspects of data governance. And other important aspects is that those testing need a specific design into the project. So to include that time and resources to have a well-established feedback loop with the users of the tools. For the future, yes, we are in the dilemma of this balance between general functions and specific functions needs according to the specific crops or systems. But here we see a potential of develop. So the further develop should have some specific modules around specific crops or specific data. And then the role of advisor in knowledge and information gatekeeping from and to the farmer. So training the advisor and what are the risks of this data management, and the same for the farmer. And of course, we need to test it in a real condition. So that means to increase the technology readiness level of the tool. Yes, and that's it from my side. Thank you.
Thank you very much, Beatrice, for that presentation. I think it's very interesting, especially for the DST tools that PrAEctiCe has also developed. Maybe after the presentation, probably at the end, or maybe after this webinar, there could be some sort of very knowledge exchange in between, because I see that you mentioned decision between, using specific information or general information, and I know that in the case of PrAEctiCe there are specifics, crops and data information that were used. Thank you again for the presentation. I would move on to the NATAE presentation. Siad Ali, please take the floor. Thank you.
Good. So, good morning, everyone. Do you see my screen?
Just a moment. Yes.
Okay, perfect. Yeah, my name is Ali Hosseini. I'm an agricultural economist in the Farm Economics and Ecosystem Services Working Group at SOLF, the Leibniz Center for Agricultural Landscape Research in Germany. So today I'm going to present and actually introduce directly our DOPSIM Miro decision support tool. DOPSIM actually is a bioeconomic farm model. It stands for Dynamic Agricultural Household Bioeconomic Simulation Model. It is a bioeconomic. Okay. So DOPSIM is a bioeconomic farm level model written in GAMS, and in this project we implemented it into a Miro app. And what is Miro? Miro is a front end or graphical user interface for GAMS models, and GAMS actually is a programming language for building and running mathematical optimization models. So I will introduce the goals, what are the elements, and what are the results of using this decision support tool. But before that, I just want to give you an overview of the whole modeling chain of the model, the NATAE model, because this is actually the exact modeling chain we embedded into the Miro app. So first of all, in NATAE, we were in charge of work package 6, and we were responsible for co-designing and simulating policy strategies to foster agroecological practices in North African countries. But in order to do this task, we needed the first 2 rings of the whole modeling chain. We were also parts of work package 2 and work package 3 in this project. The first ring, which we built in NATAE, was building the DOPSIM farm level value chain model. So the idea was to add the farm level value chain into the whole bioeconomic farm level model, because as many of you perhaps know, the main idea of bioeconomic farm models is providing optimal production plan. But we wanted to include also the upstream and downstream value chain. That's why we needed to further develop the existing version of DOPSIM by preparing and including a value chain module. And also we needed to introduce agroecological practices directly into the model. So it was another component we added. And also, as livestock production is a main activity in many of the living labs we had in this project, we needed also to further develop livestock module. So this was what we did in the first ring. Then in the second ring, in work package 3, we included multi-criteria decision framework into DOPSIM. Why? Because we were going to design finally optimal production and marketing plan that are not only economically viable, but also from social and also environmental point of view are optimal. So it was the second ring, and using this in work package 6, we were able to simulate and optimize the co-designed policy strategies that we did in work package 6. So in order to give you a better understanding of the platform, I directly go to the DSS. Now I'm showing you the Miro app and the component we have in this model. I try to describe everything here. So in order to running each bioeconomic farm model, we need lots of data. We need actually 4 different groups of data. We need, first of all, to know what are the potential activities farmer can do. Then we need price data in terms of both input and outputs. We need also the level of endowments of different inputs farmers have at their farm, the level of their land availability, labor force availability, and other resources. Also, we need to know about technical coefficients, or what we call simply as input-output matrix, simply for how many units of each input we need to produce one unit of output. So we need to have very detailed data from each farm. Otherwise, we cannot model. Otherwise, we cannot recommend any optimal production plan and also any marketing plan. So what we did in the project was, first of all, we identified different farm types from each living lab. For example, what I'm showing you are different farm types we identified in Luxor, one of the living labs we had in the project from Egypt. As you see, we grouped them into different clusters. First of all, diversified farms, commercial farms, or those farms which mostly crop-oriented, and also those parts of farms which are mostly livestock oriented. So we group them also into cattle only, cattle and small ruminants, and also all livestock. And in all cases, you see we have 2 sets of data. Actually, each of these categories I'm showing you includes the detailed data I mentioned and we need for running and recommending optimal production and marketing plan. In all cases, you see we have simple and including new varieties, because the idea, especially in this project, was focusing on agroecological practices, and one of the practices was inclusion of new improved varieties. So in all cases, you see, in addition to the normal or existing set of activities, we can test inclusion of new varieties also. I select one of them. For example, if I go for commercial farms, by importing all detailed data will be uploaded into the platform. And then the advantage is farmers don't need to go into the platform and input all detailed data. First of all, they just need to identify the similar or the most similar farm types to their farm, and then by importing data, as you see, they can just go and adjust the data. We have different sets of data. I try to very shortly describe them. So as you see, we have crop-related data, livestock-related data, perennial and agroforestry-related data, and the rest I will describe later. But from about crop-related data, the first set of information for sure is to clarify in the system that what is the acreage of each field in the farm. So here you see the first data we have, as I said, is from the representative farm we have from this specific farm type. But as I mentioned, farmers can go into the system and adjust this data. So if they have more fields, they can also add rows, or they can also remove. They can also change the acreage. They need to determine total availability of family labor they have. They need to determine the selling price in different markets. So as you see, this specific farm type has the feasibility of wheat, corn, sugarcane, alfalfa, and corn grain selling into different markets. So the different level of prices also need to be mentioned. So if they are acceptable for the farmer, it is fine. Otherwise, they can go and adjust. They need to also forecast the yield. So how many tons of each crop they expect to have from in each hectare. So yield data, nitrogen content, because one of the main constraints in the model is fertilizer ordinances. So, we need to take into account not only physical and financial constraints, but also all environmental and legal constraints. So we need to know the nitrogen content of each crop. Also, nutrient content of each crop production I mentioned. So, no, sorry, the nutrient content of each crop is for because one of the goals also in this platform is to determine the optimal ration of livestock. If livestock production is part of the activities, that's why we need to know the nutrient content of each crop. So this is also a part of the information. Dry matter content, it is also important in terms of designing optimal ration for the animals. Current year cropping pattern, previous year cropping pattern, labor requirement for producing each crop. This is one of the main technical coefficients we need in the model. Water requirement of each crop. So as you see, in all cases, we have some initial data, so farmers can go and accept them, or they can adjust them in all cases. The information about other types of inputs they need, for example, seed, how many kilograms or of seed they need for producing each crop. Input cost, so price data are very important. It will affect the level of profitability of the farm. So it is very important also this set of data. Maximum input supply. So if there is maximum capacity from in each input market, they need to clarify here. Minimum crop demand, in case farmers have some contracts with some buyers in the market, they need to specify here. Labor hours per ton the farmers need for selling the products. The distance from each input market, it is very important because it will affect transportation costs, it will affect greenhouse gas emission. So distance from different input markets. Labor force requirement for input transportation. Distance from output markets, so from the buyers also. This is because, as I said, we cover both upstream and downstream value chain. Transportation costs for buying inputs, and finally transportation costs for selling outputs. More or less the same data, but from livestock point of view, we need also to mention, I just review the main elements. So total available family labor force availability for livestock production is one of the information. The yield for exit products, how many kilograms of meat or live animals the farmers expect to have. Recurring products, so milk, butter, cheese, so other recurring products farmers can produce from livestock. Manure yield, because manure is an important fertilizer that can be used in crop production. It is also important. Selling price of different livestock production. and the rest of data you see. So they're more or less the same data we had for crop production. Also for perennial and agroforestry data, there is no data here, as you see, because this specific farm type from Luxor, they didn't have any agroforestry or perennial crop production. That's why, as you see, it is empty, but farmers can also go into the platform and complete and input their own data in case they have also agroforestry production. So this part, as you see, will prepare the actually the constraints of the model. But now the idea is to recommend optimal production and marketing plan, and it is very related to the objectives of farmers. Because when we say optimal production plan, it's important that which indicators we are going to consider in this optimization. Is it only a production plan that takes into account profitability, or also it takes into account environmental and social concerns? So this part is very, very important and crucial. I will mention also later, this DSS is not only usable for farmers, but also it can be used by other groups like advisors, scientists, and also policymakers. I will specifically show you later on the policy levers, and will show you how policymakers can use specifically this part, this objective function part. So, but as a farmer also, if I want to have a recommended optimal production and marketing plan, here I need to mention which element is important for me. So as you see, we have included 6 different components in the objective function. I, as a farmer, need to define my priorities. For example, if I go and set the weight of gross margin maximization as 1 and the rest elements 0, it will give me the production and marketing plan that only maximize my profit, and it will not take care about social and environmental indicators. But as you see, I can give up, for example, I can set the priority or the weight of gross margin maximization by 90% and include other indicators. For example, here you see, in addition to gross margin maximization, we have water use minimization, job creation maximization, greenhouse gas emission minimization, biodiversity maximization, and also nitrate leaching minimization. So these are the elements that I will try to show you some examples that by changing them, I will have new recommended production and marketing plan that take into account all other non-economic factors. So in addition to this, we need also to determine some important scalars like the mean value and the standard deviation of precipitation, which is very important. It affects yields, also it affects the amount of nitrate leaching. We need to determine usable field capacity. So if it for sure depends to the type of soils in different farms. Also, the level of discount rate, which is very important. It varies among countries, and it is very important. You know, the higher discount rate shows actually the uncertainty about the future. So when you go for higher levels of discount rate, which is a composition of interest rate, inflation rate, time preference, and also risks. So the higher levels of discount rates will reduce the current value of future profits, future incomes and costs. So it is a very important element. So if we set it as 0, for example, then the weight of all existing and future incomes and costs will be the same. But so if it is, for example, 4%, or if in North African countries higher, so it will affect for sure the results. We need to also mention the wages for crop production, wages of hired labor force, because as you saw, we include in the first place the information about family labor force, but we need to also take into account the access to hired labor force in case the family labor force is not enough. So the model needs to also recommend the farmer to hire some labor force from the market. So the wages are very important for crop production, animal production, agroforestry production. And finally, it's also important to determine how many different crops can be cultivated in a single field. It is a function of the size and also the type of technologies we have in the farm. So this part somehow fulfills the objective function part of the model. But very important element here is agroecological practices, which was the core here in NATAE project. As you see here, farmers can test inclusion of different agroecological practices. For example, if they want to do activities for soil protection, for example, by mulching or keeping crop residues at farm, or not plowing, or using raised beds, anyhow. So if they want to do these activities here, they can go and select yes. So it means we want to test the inclusion of this specific agroecological practices. But in this case, they need to also mention their estimation about water saving, what percentage of water saving we will have in case we go for these soil protection activities. Or they can test another groups of agroecological practices. For example, if they want to use or they want to improve their irrigation systems by installing drip irrigation or sprinklers. So they can here go and test yes or no. And so exactly the same. They need to determine what percentage of water saving they will have in case they go for example, drip irrigation. Here they can select. Or, for example, if farmers are going to mix trees, legumes, or other crops that naturally add nitrogen to the soil, so they can go for these groups of agroecological practices. But in this case, also they need to determine the share of mineral nitrogen replaced by biological nitrogen in their system. So this is also important. And finally, for example, these are not the only agroecological practices we test in this project. So our colleagues in work package 1 of NATAE identified a huge list of agroecological practices, but in each living lab, we are going to focus on those activities that are feasible in that specific living lab. So, but the last group here we have here for Luxor is inclusion of hedgerows or buffer strips. So this is also a set of agroecological practices that will affect nitrate leaching. That's why here also, first of all, we need to determine how many kilograms of nitrate leaching per hectare per year would be avoided when we go for hedgerow, implementing hedgerow or buffer strips. And also here we need to determine, the maximum share of each field that can be buffered. So this is also very important. In order to show you just one example, here I set it 1 in order to just enable model to select the optimum share. So I put it as 1. And here I first run the model by setting the weight of gross margin maximization as 1. So this is now the only element which will be considered in the optimization. If I solve the model, so it starts to solve, and you will see the results. It will solve 6 times because we have 6 elements in the objective function. It needs to not only solve but also normalize these elements in the final objective function. It's now a bit slow because of the connection, but this app also can be run without a need for internet connection, but in this case users need to have a license. But if they want to use the platform, we have this model in the cloud, so then there is no need for any license. They can directly run the model in the cloud, but so it will take some time for running. But as I'm also sharing my screen now, also it affects the timing a little bit. I hope it is the last run. So once we have the result, I can show you the optimal cropping pattern and marketing plan for all activities. And then I want to also test with different levels of importance for different elements of objective function. As you see here, we have 3 groups of results: production, system and value chain, sustainability and impact assessment indicators. It's a bit slow, and finally profitability and performance. So I start with production, system and value chain, just an example. So as you see here, farmers will see what is the best recommended activity for each field. So as you see, for the field 1, sugarcane is recommended, for field 2, wheat production, for field 3, corn, and for field 4, corn and also alfalfa. This what you see here is the average value of different years. I can show you also the results per year. So here you can see the results also per year, or the users, can select different years and see the results in different years. In addition to optimal cropping pattern, they can see the optimal ration. So the fodder use, you see the recommended ration for different groups of livestock at farm. Upstream value chain for crops. So in order to have the maximum possible profit, what are the optimal markets to buy different inputs? So you see we have different markets: governments, farmers, and also private companies. So you see what is the optimal distribution of buying each input from different markets. Upstream value chain for livestock first. So yes, so I'm sorry. So the first one was upstream value chain. So it shows the optimal input markets, and here we have optimal input markets for livestock. So how many kilograms of alfalfa grain and meal because in addition to what farmers are producing at their farm, they need also to buy some elements from the market. So it shows how many units of alfalfa, grain, and meal they need to buy from different input or fodder sellers. In terms of downstream value chain of crops, you see it shows the output markets. So the best buyers in the market is identified, and finally downstream value chain for livestock. In case we have also agroforestry practices, they will see also here the upstream and downstream value chain of agroforestry activities as well. Here we have the sustainability impact assessment indicators. So we have economic measures, including maximized gross margin and operating profit, social measures, including job creation or level of hired labor farmers need to hire from the market. It's very slow now, so it relates to our connection. Let me close some. Videos, maybe it works better. Sorry, try to go back. Social measures. So yes, so maximize job creation, and finally environmental measures, including nitrate leaching, water usage, biodiversity, and yes, and each of these elements also we can see separately here. So users can select, for example, to see biodiversity or nitrate leaching or water usage, and also each of them separately. Let me to describe you also this part, which is very important, policy levels. So policymakers also can test different levels of policy options. They can see the effects of payment for carbon sequestration. They can test different levels of payment for diversification. They can test different levels of subsidy for establishing buffer strips. They can see the different levels of support for irrigation efficiency, and also they can test different levels of tax on mineral fertilizers. And by changing them, I hope because of the connection, I can show some results. So if a policymaker want to see what is the reaction of farmers if they set a specific level of tax or a specific level of subsidy, for example, for buffer strip, they can set these elements, they can run the model, and they can see the results. And in all cases, as you see here, also we have a part related specified for compare scenarios, and they can see the results and compare all scenarios. So, for example, in this case, this is the average level of cropping pattern. Using this compare scenario part, we can also compare this result with the first result we had. And also, as I said, users itself can play around with these priority levels, and they can set them into different levels and see the effects on their optimal production and marketing plan. The final point I want to mention is that policymakers, this part is also very useful for policymakers. For example, they can see if they don't support farmers with any subsidies, or they don't restrict them with any levels of tax, and in case they can affect the preferences of farmers to change their priorities in terms of economic and social and environmental goals. What is the target optimal production and marketing plan? They can have it, and they can set the levels of specific policy levers in a way that they can target the same levels of production function. It means this platform can, make policymakers flexible to select the optimum level of different policy levers that bring them the final optimal cropping pattern and marketing plan that it is in line with a new level of preferences for farmers. Sorry, I don't have much time to go into more details, and also it's very slow because of the connection. I hope in another opportunity I can give you more details. Also, I need to mention that we are integrating other policy levers, other agroecological practices into the platform, and it is still ongoing activity. Thank you so much.
Thank you very much, Ali. That was a very, very insightful presentation. Thank you. If you don't mind, you can maybe share with us what you do not have time to present now. You can just share it with via email to the other projects if you find it very interesting. I think my major takeaway from your presentation would be how the platform allows specific data, and it's not just for maybe consideration of production costs, but for economic and social costs as well, for optimal production, right? And at the end of the day, I think this would also help cost reduction, because if in all this data you can see your optimal, what leads to your optimal production, I think farmers or end users will be able to make certain decisions that can help them reduce cost. And this is also very, very relative to the PrAEctiCe project. One of the objectives of the PrAEctiCe project is to make sure that there's some sort of cost reduction in farming practices in East Africa and in Africa at large. Thank you very much. I will just open the floor to any question from any body, or if you just like to, give maybe a final note or an addition to whatever has been said today. If there's just any question, we'll just take that. I think I have one particular question for Ali. You mentioned that the platform is useful for policy makers. Because I see the technicality of the platform, it's very, very technical. Is it useful for farmers, for smallholder farmers, or just extension workers or people who have maybe some sort of technical background? I think that would be my question.
Yes, it can be useful. Actually, here we didn't include the data from a group of farmers that we identified as smallholders also in this living lab. So for sure they will have less data to see and to adjust. But in that case, maybe, especially for maybe farmers from North African countries, they need also some advisors to support them in terms of understanding the priority of objective function elements, But even small holder farmers with basic understanding from what is profit, what is cost, what is revenue, they can also use the platform for sure. But maybe in more advanced cases, they need also some advisors or some people to support them. Yeah.
Right. Yes. Okay. Thank you so much. Any other question from anybody? If not, I'll just thank everyone for their time. The presentation was, in fact, an amazing one. I personally learned a lot of things, and I know that this exchange of knowledge and expertise would definitely be taken into account, in different, activities, agroecological practices and activities that each project is. So thank you very much again. Thank you for this amazing session. It was in fact very insightful, and we would, communicate with each other via email and continue, the good work that we are doing. Thank you so much. Enjoy the rest of your day. Bye.
Thank you. Thank you.
All right.
Bye bye. Thank you.
Bye.
Thank you. Bye.
Bye.